Hey, it's Mr. Allred, and I want to talk about operations that involve multiple functions, or what may appear to be multiple functions. Here we'll combine a couple of sections together with piecewise functions, operations with functions, and composite functions. So the first place to start is piecewise functions. A piecewise function is a single function that contains multiple parts that are assigned to different parts of the domain. Keep in mind this is still a function, so every input has exactly one output. So what we have down here to kind of clarify what's going on is we have f of x, and then we see a two-piece function. The top one says negative 2x plus 4 if x is less than negative 3. So this part over here on the far right is like a domain issue. And then the part on the left is the calculation. So in the top one, if we pick an x that's less than negative 3, that means we will use the top one. We will plug it into negative 2x plus 4. Now, the bottom row says x squared minus 3 if x is greater than or equal to negative 3. So if we pick an input that's bigger than negative 3, then we'd plug it into x squared minus 3. So we would never take a single number and plug it in both places because it's a function. And a function has one output. So if I gave you the number 4 to plug in, you would not plug it in the top and the bottom. You would say, I'm plugging in 4. So something like this. We'll do another example in a moment. But f of 4. And we would look at the two pieces, and we would go all the way to the right and say, is 4 less than negative 3? The answer would be no. We'd move on to the next one. Is 4 greater than or equal to negative 3? And we'd say yes. So we would take 4 and plug it into the second one. And 4 squared minus 3 would be 13, I think. So this has a single input with a single output, and it produces an xy point of 413. I try to explain piecewise functions kind of like taxes. When you go to do your taxes or your taxes are calculated, over on the right hand side here with the greater than or less than, you would kind of look for your tax bracket. Do I make between a certain amount? Do I go to the next tax bracket? Whatever. And then when I determine what bracket I fit into, then there's a formula or a percentage that goes along with it. So basically, whenever we're calculating these, we need to know what number we're plugging in first, and then that tells us whether or not we go to which function over on the left-hand side. Kind of keep that in mind. Okay, let's go to this same one, but maybe let's use some different numbers. So I've got the same function. Same piecewise function I just talked about, and we're going to plug 5 in. Excuse me, negative 5. So negative 5. We come over here, we say, is negative 5 less than negative 3? The answer there is yes. So we'll plug it in the top one, which is negative 2x plus 4. So when we plug negative 5 in there, it looks like we'll get 14. So be careful with those signs there. The next one, negative 3. Well, go to the first one. Is negative 3 less than negative 3? Technically, no. Is negative 3 greater than or equal to negative 3? Technically, yes. So we'll use the second formula. So negative 3 squared minus 3. That's 9 minus 3, so I think that gives us 6. Let's make that a more appropriate 6. I think it looks good enough, but I don't want anybody to get confused. And then the last one, f of 2. So I'm going to plug 2 in. Is 2 less than negative 3? No. Is 2 greater than or equal to negative 3? Yes. So I'll use the second one. So 2 squared minus 3, that will give me 1. So it's possible, depending on the way our function is defined, that maybe there's nowhere for the number to go in. Maybe it doesn't fit anywhere. If that's the case, then it's just not part of the domain. If you find a number that does fit in multiple places, then you don't have a function, and that's a real problem. So we hope that doesn't happen to us. Alright, so let's talk about how we graph these things. So really each one of these things, negative 2x plus 4 and x squared minus 3, each have their own individual graph. But we got to focus on the part over here, this list of domains. So for the first one, we've got when x is less than negative 3. So I'm going to come down to the graph, and I'm going to say here's negative 3, and this is the section over here where x is less than negative 3. So how I'm going to graph this is I'm going to put one function in that domain area, and the other one that goes when it's greater than or equal to negative 3 will be graphed on the other side. Okay, so our graph is going to be split basically into two parts. Okay. And we're going to use the corresponding function to go along with that graph. So this can kind of help ourselves out here. So y equals negative 2x plus 4. So what do we know about that? It has a y-intercept at 0, 4. It's a straight line. And it has a slope of negative 2 over 1 if we like. So let's try and graph this. Let's see here. So what can I use? I guess I could use red. So if I graph this as I normally do, 0, 4, and then down 2 over 1. Ugh. I may fall off my graph here. That's not good. I may not have picked the right example. So normally the line would look something like this, and it would go all the way across. But we're only using this in the yellow part. And if we see this less than negative 3, that's an open circle. So I'm going to come up here. Well, I'm going to go ahead and complete this line. And I'm going to put my open circle up here. And I'm going to come back and I'm going to erase the part that I can't use. And I might kind of clean this up here a little bit as well. So starting at negative 3, if I plug that in, I should get 10. So unfortunately, when I made this up for the other part, I picked something that didn't work out so well there. Okay, but this part right here is for the negative 2x plus 4. The other one, graphed on the right hand side, is x squared minus 3. Well, we can do this a variety of ways, but no, it's a square function. Shifted down 3 if we've done transformations. So we would take this thing that we've got and we'd take the square function, which is a parabola centered at the origin, and shift it down 3 down here. And normally that would be a U shape coming up on this side, on the left side, and mirrored on the right hand side. I'm not being too specific. But we have to kind of come back and see that we want this thing to kind of break off on the left hand side so it doesn't cross over this negative 3 threshold. And it might not be such a bad idea to throw this negative 3 in and see that we've got the point negative 3, 6. So I'm going to erase some stuff on this left hand side, and I'm going to say that negative 3, 6 is right here. And that point is included because of the greater than or equal to. And I'm going to try and draw this thing up to that point. So there's a gap there on the y values over at negative 3, but it's still a function because the vertical line test would only hit at one place. So it's a function, and it was graphed in parts. Okay? So it's very important to identify the parts or the places those parts will be. Okay? So we have solving techniques and graphing techniques. And you may have to graph more than you need and come back and erase it. Let's try one more. So we're going to try and graph this thing. It's a piecewise function, and it says the first piece is the absolute value of x plus 4 if x is less than or equal to 0. So we can kind of just jump on that with no problem. We can come over here to less than or equal to 0. And we can try and say, uh-oh, pen's getting stuck. What's happening? Okay, I think we're back. So that's the function y equals absolute value of x plus 4. We know that absolute value is the V shape. And what it says, this +4 inside means it's going to go to the left 4. So it's a V shape that's usually centered at the origin, but it's shifted over 4. So to the left, so right about here. So it's a V shape out of there. And let's see, it's going to go V this way. And it is included, but it stops when x is 0. So it looks like that. Okay. The left side keeps going left forever. The right side stops at 0. Okay, so that's the top one. The bottom one is negative square root of x and then -2, and that's for when x is greater than 0. So we'll put it in x is greater than 0 territory. So let's see here. Negative square root of x and then -2. So that negative out was a square root function, squared. So that negative out front reflects over the x-axis. And the -2 will shift down 2. So squirt usually comes out of the center and goes up this way. It usually looks something like that. But what we're going to do is we're going to flip it over and move it down 2. So flip it over and move it down 2. Well, I'm going to open circle. Missed the eraser. I think something's happening. Bear with me. There we go. So open circle and upside down. So about like that. So I'm going to come back and I'm going to erase the top one here. So this is our piecewise function. We definitely don't want both of these points on the y-axis to be solid because the vertical line would hit it twice and it wouldn't be a function. But it also shows that if we plug something in, depending on whether or not it was positive or negative, we'd calculate a completely different way. That's a completely different trend there. So all the things we've done for graphing lines, quadratics, and the parent functions and their shifts will allow us to make some variations and put pieces of graphs together. Even if we have to graph more than we want, like graph a complete absolute value function and then come back and erase part of it to limit the domain, that's what we'll do. All right.